And hello everyone. Right. Hello everyone, welcome to the third session of the Golang screencast. Today I am going to talk about Go routines and Go channel. So the exercise that we are going to do is that we will try to write to a file, then try to read from it again, so that in case somebody who missed the first one get used to some of the better functionalities of handling a file content in Golang. So this is called, I'm going to create application call generator. This will be generating the test file that we are going to use it afterwards. Oh, I'm actually doing a weekly Golang screencast, so it's about getting people to familiar with how Golang works. So in this program, we are going to create a file. So create a local file called I'm gonna call it document.txt. If you can close the files, always close it. Always use a defer to close it to make sure that if your program exits in the middle abruptly, it will be terminated properly. So as you can see, I'm using an autocomplete. So the only plugin that you need to install if you are using VS Code with Golang is the Go plugin from Microsoft. So let's write something. So we are going to import. You can do an input like this. Imports. Okay, I'm gonna change it of IO. Wait. Yeah, I actually forget how it works, so let me look at the documentation. So this is where we look up for the documentation, Golang file. So by default, we can actually write anything that we want this way. Hello world. Okay. I'm gonna give some name, Bob and Alice. So this is how we use it naively. So let's get Go run main. What Go run does is actually because Go actually the compilation of Go is actually very fast. So Go run is actually compile the binary and put it into the temp directory and run it from there. Okay, this is the document that we have, but we don't want to use it this way. So what we want is a writer. It's above IO. I'll explain why it is so I prefer to use it. So I'm gonna give you a name, buff.io, new writer. Oh, you see what we actually acquired from this function is a file pointer. It's actually a pointer to the file struct called name files. but writer actually accept an IO writer interface. So it means that the file actually implements the writer interface. So anything that implements a writer interface, you can use this. You can support any function that implements that. So what we are going to do is going to write something. Writer write string. I'm gonna save it up. Okay, what's wrong with that? It's correct. I'm gonna write string hello world and writer write. I actually need to put in the new line. Op and Alice is the same, but why do we choose a more verbose way of writing this? So let's run it again. Document. Oops. Oh, I actually need to flush it. Flush. Right. Okay. So what it does is it actually creates a buffer. It doesn't so it doesn't automatically it actually maintains a buffer size, and I think it can be shown here, but also tips: clicking on the documentation, clicking on any of these functions will show you the source code, and this is one of the way that we can learn how to write code easily. And you can see the new writer is actually initiating a writer with a default buffer size. So let's find out. Okay, so the default buffer size is this. So what it means is that 4096. So what it means is unless it exceeded the buffer size, it will be stored in the memory. So in a way, you are not hitting the disk too much, and you are so let's write some messages like some mock for our test. So for loop, I have a million lines to write. So it saves you from having to do manual flushing, allocation and stuff. So just make sure that after you, at the end, remember to flush the remaining one, so everything will be written to the disk. So let's write something so for our program to read on. We're gonna just we are going to just write the numbers. So, and Golang is actually a static type language, because write string actually accepts only string. We need to cast it to a string. So in this, you write, yep, and we got forward count, go run main, right, we ran. Oops, what went wrong with this? Yes. Oh, actually, it's actually just one line. So I actually need to put in. Oh, and also the good thing about using this is that I don't need to worry about whenever and when you write something, you do extra allocation. So all these will be just writing to the same buffer. So right, million of them. So take this out, and let's close it. We're gonna start a new program that reads from the file. So how normally we read a file is that the very common one from everyone, especially from people that just started, is to use this read all document.text. So this is the data in byte. So I am going to, oops, so what's wrong with this? I mean, let's see what the error is. I owe you too. So let's what was the error of this? Do something wrong here. Let me exit. Oh, not read. Oh, read file. Huh. The documentation is here. I owe you too. Yep, read file. I forgot about it. Huh. Right. And what's wrong with this? Oh, it's actually okay, but my program is complaining. So I only want to write. Let me reboot this. I don't understand what's wrong with that. Okay, now it seems to work fine. So I'm gonna print a bit of what we have. Just the first 10 bytes. Oh, let me convert it to string as well. Yep, it's okay. Sorry, I'm sharing the links to other places as well. It's my first time using a Restream, so this is a free service that allows me to stream to multiple endpoints. Right, I'm going to share it to the group. Share it. Silly me, I actually forgot. Okay. Schedule from here. Right, let's continue. So one of the, especially for a row new line terminated document, the one of the very common way that people when they first started they use this function to do it, so that afterwards we need to use I don't remember some of the documentation much, so I will refer this as well. So I have to split them manually. So these are called rows, bytes, split. The data, the separator will be the new line. Actually, I'm not sure if it works. Let's print the row afterwards. So let's run it. Oh, can't use a run. So I'm gonna be a byte. So let's do a time. So took us a half a second to read through 1,000 line of them, and can actually get 1,000,001 row. So this is normally how we start, but just throw this away. This is how we are supposed to do it for a new line separated document. So OS opens document.txt. Always handle your error, and if it can be closed, or it's a good practice to do a defer close. And I'm going to use something from the library that we used just now, buff.io, but instead of a writer, we're gonna use a scanner. So scanner, okay. Scanner, I rely on this a lot. For each scanner, I'm gonna get the text. So let's just read one of them. This is called a row. I'm gonna call it line then. So let's print the first line and exit. Yeah. Oh, it's start with 0. I'm actually supposed to because doing benchmark this way is actually wrong, because this includes the compile time. So what happened here is actually scanner is actually a buffer, but for a reader. So what it does, it use the you pass the document, look for the separator, which is by default is the new line, and yeah, only read it until there. And if you need more, then you can continue with more, but if you don't need more, then yeah, that's basically it. You can just use it until here. So if I want 10 lines of them, let's say I'm gonna put it as a, so these are called my lines. So I don't know, let's use this one. I'm gonna use I++. If I more than 10, break. No, I should yeah, I should put it behind here. So lines equal to append lines line. So here let's do a print. The tips to print everything formatted. Use this lines. Alright, we're gonna just read 10 of them and exit. Yeah, and the rest will be ignored. So this is actually a better way to handle a new line separated document. And also tips, if you are doing CSV processing, it actually has something similar as well. So you can read them row by row instead of just the whole document. And why that is important, I'll show you guys afterwards. Right. Okay. So what happened now is we are going to use this as the base of our Go routine practice and Go channel practice. So what happened here is I want to process this concurrently instead of sequential. So what I want is to output the result. I'm gonna double this whatever amount that we have here, the digits that we have, and write it to output file. So this is called output file. Out file. I'm gonna call it out file. And the coding convention of Golang is camel case. Snake case never recommended, or some of them it's actually better if you don't use a snake case. It's always better to use a camel case in Golang. So we are going to create a file. It's called output. File. So from here we are going to, what we get here is actually a string. So right now, before we can multiply it, we need to convert it to integer. So the library that we are going to use is, it's going to call, the library is it's very easy to remember. It's called strconv, which is a string convert, and we are going to use it. So string convert. Unfortunately, string conversion is actually, you come up with an error. So I'm gonna call it digit or number. So I'm being extra strict right now. I'm going to stop the program if any of the conversion fails, but you shouldn't do that, especially if you are handling a file with a lot of different types. So what you should do is like probably I'm gonna put it like unable to process number. So I got error to convert string to int quote what and error what. So we're gonna put the line and our error. So then we are going to continue with the loop instead of panicking. So either way, always handle your error. Don't ignore them, because if you silence the error, the program might run correctly if you're lucky. the very dangerous part is it might still run but not behaving as what you think it is. So let's comment this. So we're gonna double this. So and write it back. So and also the same way as previously, I'm gonna give it a writer. I'm gonna use the buff.io. So buff.io is actually a very good library. So out file. So writer flush writer write string let's print key with a new line. Alright, this is the very naive way to do it. And of course, multiplication is actually a very fast operation, and we are going to introduce some latency, like let's say time sleep, yeah, like for a millisecond. For example, it is going to be very slow. So for a million row, how much time are we going to need to do this? Let's put it up. So we are going to this. You can see that it is very slow, and I'm gonna terminate this, and we are going to speed it up. Let's assume that this time is here. This is a very slow operation, and this is the artificial duration that we add in. So, and yeah, this is very slow. So what happened here is we want it to be run in parallel to each others. So okay, let's start. We are going to have input channel string, and this is actually sufficient. This is what we call an unbuffered channel, and unbuffered channel will block on the first entry, and we want it to be buffered so that more can be it's a buffer, so it's like a cache, so it can be really fast. So let's read ahead 10,000 of them at the same time. So if you have an input, we have an output as well. Output is the same as well. So what the difference here is that this will be the one processing, and this is the one that is going to be get into C. So let's try this first before we complete the rest. So this will be our inside our Go routine. So Go routine, we will start this. And you can see the workflow here is going to be, unlike previously which was a sequential, it will be in reverse, so that the writer will be at the top instead. Okay, so this one is done, and when it's done we need to close it, or else the process that is going to read from the input will block forever. So if it's a bit too confusing, feel free to comment. So ignore this. So what will be not involved here is this part right here to avoid the confusions. So we are creating a channel with this type. It's basically a string channel that buffered by 10,000. So it's you can add in a 10,000 of them before it starts to block. So, and also always remember to close your channel, or else the whatever process that is going to read it is going to block forever. And this is how, up here is where we are going to start it's different. It's actually not down here, but because before we start, we have to start the function to consume this channel. So I'm gonna write the function here. So it's called just by double. Call a double. Input will be string channel. Okay, I'm gonna call it inc. That is chan. And out channel, in and out, because we are going to have an output as well. So, and I'm gonna do an explanation afterwards. So out C is a channel that allows only write. So the arrow by itself, you can use it just like this. It is fine. But if you want to limit the direction of the channel, if you want to limit it to only to only take value from the channel, you do it on the left side. If you are only supporting input to the channel, then you put it on this side. So here we won't have any errors. We are not it's a bit bad. In here we are, when we encounter an error, we are just going to print it out. So this will be a function here. So let's get it. And by default, an unbuffered channel doesn't. I'm gonna show you the traditional way of how to do it. This is called I'm gonna call it line. No, it's going to be a more inc. If there is no more channel, aka it is closed, then we are going to break this while loop. A for loop without anything is actually a while loop. So for that, we are going to convert. I'm gonna go number, error, string convert, and UI line. It's very bad. I am only going to lock it. I need to do pass string to integer. Got error. So line is this, error is this. We are going to continue to the next one. It's a bit bad. Supposedly you need to check manage your error. So for this, we need to double it and make it into a string. So let's print f d with a new line, number times 2. Of course, we need to introduce like the one just now. We need to introduce an artificial duration time sleep for 1 millisecond. So for this, we are going to write it to the output channel. And what's the problem with this is there's no way to know if we are going to start, say, output. If we are going to start 10 of the Go routine, the problem here is input chan output. We have no idea that which one of these, because we need to write everything back to the file, and we need to make sure that all these consumers and also producers will actually get what they have and output, make sure they finish all their job before we terminate the program. So what we need here is actually to synchronize between them. So we need to introduce a work group. A work group can be just can be used just like this. Sync work group. Oh, I call it work group just now, but I want it to be a pointer. Right, let me show this. Some people might not like this syntax. You can replace it with this, which means similarly. And here we are going to put in a wait group here, so that we know that we need to wait for all of this to finish. Wait group, sync wait group. So this is very simple. We do a wait group. Okay, it didn't autocomplete for me. It's actually done. And we need to add the amount of this. We could add 1. So for every one of these we add 1, or we can prematurely add 10 this way, because we know that how many of them, unless it is a dynamic parameter, then we need to synchronize it. We're gonna put it here, but since we know that we are going to add 10 of them, so always good to put because defer used to incur a more expensive cost, but nowadays it is cheap enough to use, and it saves you a lot of headache of making sure that you put everything at the right position and it doesn't terminate and assume that your function terminate properly, which is this one is proper. Put it here. I'm gonna just introduce a lot of in my opinion, best practices. So wait group here is so that we can wait. So we know that it should be waiting. So you can see the sequence is a bit backwards. So for output, I'm gonna reorganize them. Because there is no error, we can put them together. This is for the input, this is for the output. For output, we are going to just write to a file. But the problem with this is since we cannot wait for all of them to finish, then write them back, we actually need to write the output from here. And the problem with the writer is that it is not for anything that for any file IO operation is actually recommended to only have one at one time. So we are going to have this writer for each line is the same. So this line more, is there more? This output channel, if not more. Oh, did I do a not more? Okay. So writer write string line. What's the error of this? Oh, right, because I did this. I can do a defer as well, always flush. But what's the problem here is that because this goes into the background, we need to wait for it to finish writing before we exit the program. So we need, in a way to synchronize it. So what we need here is actually a done channel, which is just a channel, just a single channel that we just want one signal from it. So here, make chan, we can use a cheap one like bool. You can also have a empty strut. For simplicity, I'm gonna use a boolean. And here when we exit, we just need to close it. And here, just wait for it. Done. So for verbosity, we are going to log some. Finish reading scanning file. Workers exited. So writer exited. Right, all done. So for some of this, starting worker, of course you can assign them an ID if you like. Fine. So this should be it. So let's run it. Oh, if 1 million millisecond is actually 60 minutes, so let's reduce it to nanosecond, because it's actually artificial. So let's for it. Oh, I have a deadlock at 60. What happened here? Done. So 33 and 31. So let's find out what actually is the issue. So let's use a wait group to debug it instead of using this. Okay, some of my other codes went wrong. So out. As this is used here. Sync wait group. Next one. Defer. Done. I'm gonna wait here and state. Oh, I have a date law as well. 64. This is the one. What did I do wrong? I need to put it down here. So let's find out. This is not supposed to be it. Let's throw away this artificial one. Okay, so let's go through it. It's not supposed to be here, it needs to be on top because we need to consume it before we are putting more things inside. Always have a consumer. One. No more. Okay. No more output. So doing a bit of logging because I have no idea where it went wrong. If you can tell me, please do. Can't get it. 64. So wait to it. So after let's go through it. After I finish putting the file in, like we're finished for consuming the file, we are going to close this. And the next one is that we have 10 workers and we are going to consume this and output it. After it is done, silly me. After here, I actually it's not because of the wait group. I found it. Let's switch it back to here. Wait group is actually in a way like easier to read and less confusing. So I actually found the cause. It's actually very silly that I actually forgot to close my input channel. So that is the cause of why I have a date log, because the program doesn't know. The program is like stuck there. It doesn't. It's waiting indefinitely for the output channel to close. So what happened here is after all worker exited, I need to close the output channel. Yep, this is what happened, and sometimes it's very easy to forget about this, even like me. So here, and it should run fine now. Yep. So let's put back our reintroduce our artificial lag and stuff. No. Okay. Here, it's not much of a. I'm gonna give it more. What is 10,000 milliseconds to minutes? It's still 1 minute, so I'm gonna reduce it more. Okay, so I am going to have a 10. Yes. Yeah, it'll be still fast. So right, let's throw this away. and because it's two robots, I am more input. Okay, let me throw this away. Then we are going to do a breakdown of what sort of things we can improve from here. So here, this is the more universal way of reading and reading from a channel, but that's the problem is that is this method I'm not sure about. I think it's still sold right now. If it's buffered channel, you can actually do this directly. Instead of all these lines, but the problem is you have to know that this is a buffer channel. So sometimes in actually for beginners, if you read a few examples of here and there where they mix a buffer channel channel without the size, this won't work. So let's try it out. I'm not sure about the latest version, but last I checked it doesn't. So right now it's fine. So now let's introduce unbuffered channel. So by doing this without setting a specifying a file a length, you are using, oh, and it still works. Okay, it's changed now supposedly, or I was doing it wrong. It's always good to, the good thing about me doing this is actually in a way for me to practice my own knowledge on Golang. So yeah, we can reduce this. Of course, we want it to, for throughput, we want it to be buffered, and for this line as well. So line equal to range output, and notice you actually don't need to put in the arrow side. Yeah. For each of this, do this. Okay, I'm supposed to use this. Go in. Okay, let's do a count of the outputs. 1,000,000 of them. So what else can we improve? And you can see that it's it gets a bit especially this, it gets a bit, sometimes I prefer to do it this way, where I supply a channel and I output this. Okay, what should I call it? Okay, I can call it writer. I'm gonna write worker. I'm gonna call this all worker then. So I'm gonna call it int channel. Oh, it's actually out. It's actually my int. So I'm gonna call it the same. Technically it's an int, so I'm gonna just stick with int then. Chan string, and I am going to give out a chan bool. So done equal make chan bool return done, and this is where we are going to put it. Oh, I have a writer as well. Right, writer of IO writer. I'm still doing this inside. Oh, quite input. Do not confuse yourself sometimes, but for anything that comes in, I call it input. So here, instead of this, I got a done c equal to write worker output channel and the writer. And yep. That's about it. Yay! So is there any other questions or anything you guys want to see? So I'm going to check the chats. And for a bit of visualization, what happened here is actually from a single source. I'm doing a fan out to multiple processes. So let's assume that I have 5 workers. So from a single file, to fan out. Okay. Supposed to use all this. Okay. So worker. We have a 0, 1, 2, 3, 4. From here. Here is supposed to doesn't detect my middle mouse click. Okay. But they fan-in factory. They multiplex into back to one writer. So this is called this file. Then this is another file. This output. So this is what is going on here. Something that comes in, then go back to the same one. So I'm gonna comment this. What it does. I'm going to check the chat for any questions. Oh, and there's none. So I think that should conclude what I want to show today. And since we have a bit of time, let's do a bit of exercises. Then with channel. So let's change our terminal. Chan. So we have an A. No, we have a string. We key put in something. Hello world. Do you think this program will run? So let's have a look. Go run. It doesn't, because it is blocked at this unless there's a consumer, it is blocked. So the cheat is actually to make it a buffer channel. But the problem is that this is not deterministic. So what we do here is As here, let's see if it runs. It doesn't sometimes. The problem is it's not deterministic as well, but at least that it means that why it run is that because the consumer is there. So it's always whenever you use the channel, make sure you have the consumer done first, or else depends on your setting, because you cannot differentiate by default. You cannot differentiate a buffered channel from a non-buffered one. So it's always good to have a consumer done first. So yeah, hello world, and this is how you put it in, and this is how you output it. And let's do a bit of what sort of tricks we can use. Oh, we're gonna cover a bit of what should I cover it? Oh, and channel is not only the way to do data synchronization in Golang. It's just one method to do it, and you can actually use the very old school mutex var log sync is from the sync package mutex, and let's have an integer. So let's start several go routine. Let's have a 10 one. So go func. What's the problem with this code? I'm gonna comment this first. Plus. What happened here? So it's not supposed to. Come on. Let's put it as a data equal plus. How silly me. So what happened here is that what happened if you run this program? So the problem is it's undeterministic. It can run, but you see, we had 10 of them, but we only had 8. But let's run it again. We have 1 now. We have 5. And in some cases, the program will crash. Let's put a race detector. Yep. Do not use it in production code, but it's very good, useful in development. The race flag tell you the possibility of a race condition. So what happened here is whenever somebody try to read and write, each of them get a different state. So to synchronize that, we need to introduce a lock mechanism. So lock. So I'm gonna use a lock, and yep, to make sure that even though I can put it afterwards, it's just I just want to show you guys the one of the best practice if you have a bad memory like I am. So it will make sure that it will always unlock it. So now let's run our program with race, and so what? It's supposed to be gone. Don't know why, but we always get a 10, 13, 17, and 21. Oh, okay. Because it's not deterministic. So when I read here, okay, it be gone 9 because it was not synchronized as well. So the program you just, because whenever you start a Go routine, the program will just proceed to the next one. So that is why we use a wait group to do synchronization. So I'm gonna normally we do this in a parameterized situation where we have probably more than one, not the I. So when it finishes, I'm gonna put it defer wg done. So only that here. That's not. We are not going to need to lock it again. Let's see whether the race conditions race checker will warn us. Yeah, it should be fine now, because now we wait until the program exited, and since there is only one party that requests for this data, there won't be any race condition. So hope this is useful. Always be careful of this. Always use one. If you put an I here, you'll be running indefinitely because it can never be fulfilled, because every time we use a call a done, it will reduce by 1. And yep, the program will run indefinitely. It will hang until like it feels that it needs to stop. So be careful with this. Add 1. And what happens if you forgot done is the same as well, that the program will run indefinitely. And also what happens if we forgot to unlock? Nobody can acquire it, you'll be stuck there forever. Be careful about that as well. That is why I recommend there is some overhead with defer, but to be safe, for any safe situation, just use it unless you need the extra few milliseconds, nano to millisecond of kind of a performance. Yep, I think that's about it for today. I need to be the feedback for myself, at least from, oh, font is a bit small. All right, I'll increase it the next time because I'm wrapping it up. And I think I need to be more organized because it's just so lucky I've been having some difficulties with streaming, so I've been testing a new setup for the stream, and hopefully for the next week it will be better and will be more formatted than right now. So I think that's about it for this week, and yep, goodbye and have a nice week and happy hacking.